ratio and proportion. Let's start out with a definition. We didn't get there yet. We'll go through the rules. Let's just understand what we're talking about. Whenever you see a ratio or proportion, it's saying something's proportional. It's a relationship between two numbers. And that ratio stays the same. You know how when we have fractions, we bring it to the simplest form?
Yes.
Well, a ratio is going to do the opposite. We're going to expand it, make it to a higher form.
Oh, wow.
So it's like going backwards.
Oh, wow. Okay.
All right, so that's why I said ratios are very similar to fractions in many cases.
Is it like, you know how they say this is to this and this is to this?
Yeah, that's a ratio.
Oh, those you could do, yeah.
I can see we have a fan already.
Yeah.
All right, we got the definition.
Right.
Well, I think you're going to get them this time. All right, how do we express a relationship, a ratio? It's expressed three ways. Let's say our relationship is for every 3 we're going to have 4, right? It's usually separated by a colon, like this. Read 3 to 4. Okay, we'll do a side. Okay, that's one way.
What's the other, that word already expressed?
Expressed.
Expressed.
The way they identify it. Another way they could say it is 3 to 4. Not the number 2, but the letters T-O. They can say the relationship of these two items is 3 to 4. So they're saying for every 3 of these, you're going to have 4 of these. Like say this could be red, this could be green. So for every 3 reds you have, you're going to have 4 greens. The common way is 3 over 4.
Oh, we recognize that.
That you recognize, right? That's
Yeah.
4. They say the ratio of something is 3 to 4. Let's say, what are we doing here? We could say we're cooking, right? And let's say for every 3 of something, what could that something be?
3 cups of flour.
All right, 3 cups. We're going to need 4 ounces of some other item.
Yeah.
But it really doesn't
Water,
matter.
whatever.
All right. Well, let's say our recipe calls it to be a little bit larger. I think the easiest way to calculate with a ratio is change it to a fraction. Okay. So let's say, in this case, we got 3 cups of flour here, we got ounces. And remember, if we have cups in the numerator, we have to have cups in the numerator here as well. The units have to be the same horizontally.
For numerator.
So this is going to be ounces, this is going to be ounces. The same for the denominator.
Oh, okay, okay.
So if this is cups, this has to be cups.
Okay.
If this is ounces, this also has to be ounces to have a proper ratio.
Okay, right.
And let's say for some sake of reason, well, we said that we got 8 ounces,
Okay.
or whatever this solution is. All right, so somebody said 6. All right, how did we figure that out?
Times 2.
The relationship between this number and this number is going to be the same as the relationship between this number and this number. Now, to get from 4 to 8, we had to multiply by 2. Remember with fractions, if you do it to the numerator, you have to do it to the denominator? Same thing with a ratio.
Right.
We got 3 here. If we got to multiply the 4 by the 2, we also have to multiply the 3 by the 2, and we're going to get 6 over 8. This is saying we're going to need 6 cups of, what was it, flour we said, to 8 ounces of whatever this other solution is. Why do we multiply by 2? Because to get from 4 to 8, we had to multiply this by 2. It was given. We're just saying.
I was just going to say.
We're expanding
the
it.
number's going to be given, or we have to figure it out.
Yeah.
Let's try this.
Okay.
Let's switch the problem around a little. Since we're on a cooking theme.
Right.
You know how when you have a pound of meat, you usually have to cook it for 20 minutes at 350,
Okay.
for those of you who cook,
All right.
right? So let's say for every pound, I'm just going to put the units here, pound, it's going to be 20 minutes, right? That's the ratio. For every 1 pound of meat, it's 20 minutes of cooking time at 350. All right, now let's say we got a 6-pound roast.
Oh.
All right, so over here we got a 6-pound roast. How long are we going to have to cook it for? We don't know, right?
Oh, that's going to be it.
All right, let's figure it out. We're going to change this to 1 over 20 is equal to 6 over x.
because 6 is our,
Yeah, see,
what we
here's our
have.
ratio.
Yeah,
Is for every 1 pound, it's 20 minutes.
right.
Over here, we know we got a roast at 6 pounds. We want to know how long do we have to cook this roast? All right. So let's look at our numerator.
Okay.
What do we have to multiply 1 by to get to 6? 6, right? So we got to multiply this by 6. So what are we going to multiply this by?
6.
So x is going to equal 120 minutes.
Oh.
So now our ratio is 6 over 120, or 6 to 120, which is equal to the ratio of 1 to 20. See, this ratio and this ratio are exactly the same, because the relationship between these two numbers is the exact relationship between these two numbers.
Okay.
Now,
So it wouldn't matter to you how we write it?
what do you mean?
Like, we can write it either in a fraction or in the...
You could write it in any of these 3 forms.
And they all mean the same.
They're all the same. When you're calculating a value like this, it's going to be a lot easier to do it this way. You can do it as with the colon method, but it's a lot harder. It's usually more confusing. The book does it that way, and I would strongly suggest don't do it that way. Do it with the fractions. It's going to be a lot easier.
Yeah.
Okay? All right. Well, in this case, we calculated out if we wanted to go from, let's say, a 1 pound roast to a 6 pound roast. Let's ask ourselves, what other ratios would be equivalent to this 1 to 20 ratio? Let me show you how we're going to do that. I'm going to take this down. I'm going to put my 1 to 20 ratio over here. Then I'm going to put 2, 3, 4, 5, 6, 7, let's throw an 8 for the measure. If I wanted to make another ratio, an equivalent ratio, if I multiply my numerator and denominator by 2, what am I going to get?
2 40s.
2 over 40. Now to find this next ratio, I don't multiply this. I go back to my original ratio. If I multiply the 3 times 1, I'm going to get 3. If I multiply the 20 by 3, what am I going to get?
6.
All 3 of these are equivalent ratios. Let's say I wanted to multiply this, expand it up to the 4th time. It'd be what? 4 over 80. Now before we go on, let's look. What do we notice? Is there a relationship here? What is it?
Sequence.
These are progressively increasing by 1.
Yeah.
So let's say when the numerator increases by 1, what does the denominator increase by?
Tiny.
Oh, isn't that the same as this ratio here? Works out.
Wow. Okay.
All right, with that in mind, what's this one going to be? 5 over? All right, let's go to the next one. It's going to be 6 over? 7 over? And 8 over? So we could expand this ratio here out to any one of these forms. And we can keep going forever. There's no ending. It goes on infinitely. But you'll notice that the difference between the numerator here and the denominator here is still 1 over 20. That's why it's an equivalent ratio. You got it? All right. She said if this were 2 over 20 as a ratio, what would the next equivalent ratio be? 4 over 40. What would the next one be? 3, 6, oops. 6 over. What do you notice between the difference between here and the difference between here? This is 2, this is 20. It's the same. Over here, the difference between here and here, it's 6 minus 4 is 2. Difference between 60 and 40 is 20. So it goes back to the same ratio.
I'm sorry. Okay.
Let's do a word problem. I'm not going to write it all down, but I'm just going to tell you what it is. It says there's 25 male students and 75 female students. What is the ratio of male to female? So let's write down the critical information. 25 male, 75 female. Now they want to know the ratio All right, the ratio of male to female. Now, this is, doesn't that look like this format here? 3 to 4? So we want to know male to female. So here's what we're going to do. We're going to start out with, we have to have the males first, right? Now we have 25 males, so let's put 25 right here. The 2 becomes a colon. The number of females we have is 75. So our ratio is 25 to 75. But we're not done, because that's not correct.
We still gotta find out the
Just
ratio.
put it on,
of it,
make it a
right?
fraction?
Let's make it a fraction, that's a good idea. 25 over 75. Remember, when we were working with fractions, we said fractions always have to be in their simplest form.
Right, right.
Well, ratios also have to be in their simplest form. You can expand them out when you have to use them, but when you're identifying the ratio, it has to be in its simplest form.
You divide them?
And when you get the answer, it has to be the simple function.
No, because when you get an answer, you're going to be expanding 90% of the time. So here, let's just say, even though we know it's a ratio, let's just say it's a fraction, just for instructional purposes. Well, this ends in 5 and this ends in 5, but we know both these terms are divisible by 5.
Right.
So, well, if 5 works, what did I say to use next?
25.
Yeah, try 25. Well, 25 goes into 25, obviously. 25 goes into 75.
3 times.
3 times, so let's go
One
like
male
this.
to every 3 females.
So this is going to be 1 over 3. So the ratio is there's 1 male to every 3 females. Which reminds me of a funny story. You want to hear it?
Sure.
Okay. My son wanted to go to this college. And it's Mount St. Mary's. Anybody ever hear of it?
Where is it?
Newburgh, New York. And we're walking around the college. Excuse me. And he was saying, this place is small. He really didn't like it too much. But he wants to play basketball. So we went and we talked to the basketball coach. And the basketball coach says to him, well, I'd just like you to know that the woman to male ratio is 3 to 1. My son turned to me and goes, I like this place. That's important.
That's important.
To be honest with you, I wish I could do that college when I was his age. All right, enough of the buffoonery. All right, everybody understand this? So here, they gave us 25 males, 75 females. They wanted to know what's the relationship from males to females. All I did was write down the number of males, number of females, put it in fraction form, reduce this to its simplest form, and then the ratio would be 1 to 3. Or we could leave it like this, either or.
Okay.
Here's another word problem. We got a 1 to 5 solution. So it's 1 to 5. And the solution contains 1 part medication to 5 part solution. So this is 1 part medication. And this is solution. All right, 5 units of the solution. How much medication is in there? So how do we solve that? Well, we're going to start out with our ratio, right? 1 to 5. This is medication, this is solution. So for instructional purposes out here, I put medication.